Hey everybody, Jamie is back. Uh, I'm probably a little better than 50%, something like that. But I'm ready to do a little online teaching here and it's bringing back some memories of a year ago. Not necessarily the best memories, but anyway, I'm doing great. The recovery is going well. No complications yet, and it's kind of going as expected. I'm doing my exercises and physical therapy, so it looks like I'm on course to um, be back in January, unless things get a lot better or a lot worse between now and then. So keep your fingers crossed, and I will stay the course and work hard to get back. So it's good to be back, but we need to kind of get ready here. We're going to plow through general chemistry. As I mentioned before, we're going to go through this at a fairly rapid pace. Um, and we we're going to do this week. We'll do this video or videos today. I don't know how many it's going to take here, but uh, and then some practice problems tomorrow that sort of practice what you're learning today, in addition to some practice problems that I'm going to give you today. And then Friday is the quiz on chapter 2. That's right. We're already taking a quiz here on this stuff. Okay. Um, Again, we can go through this rapidly because you guys have seen this before, certainly. And it deals with numbers in chemistry. And by the way, I did post this presentation. You will be allowed to use this along with any practice problems you use on the quiz on Friday. So that's up to you if you want to take notes or if you want to reference this on your computer. Um, it's all written there for you. I do recommend that you work through the stuff as we go through it here. Okay. So the first thing we're going to talk about is just reviewing significant figures, and what I've tried to do is just isolate sort of the additions and clarifications that they do at Southeast Tech that we may not have emphasized as much. For instance, the concept of an exact number, um, where there's no uncertainty associated with it. And in other words, it is not a measurement. And most of what we deal with in chemistry are measurements of some kind. But every once in a while, you'll be counting, all right? Um, and or doing a definition. So, for example, things that are not measurements as a definition, 1 foot equals 12 inches. Definition. Okay. There are no significant figures. You wouldn't say 1 foot has significant figures, or 100 centimeters in 1 meter. That's an infinite number of significant figures, if you will. They are exact. There is no uncertainty in the measurements. And counting, this is when you can count something exactly. You wouldn't be estimating, because that would have uncertainty. But if you're counting, like, there are 26 awesome students in general organic and biochemistry this year. And it's not plus or minus any, so counting is another example. And of course, a fraction. We talked about this a little bit with half-life, that if you cut something in half, you're cutting it in half exactly, and that is a mathematical function. Okay, so you can eliminate those exact numbers from your significant figures. Um, Now, some of us are going to need more review than others on significant figures. I have a page reference here for you, page 29. If you want to pause the video and go over the guidelines for determining significant figures, especially Rule 2, which says when are zeros significant, and then try these problems. after you've gone over that page, that would be great. So I will see you in a little bit. Go ahead and hit the pause and try these 6 problems after you have reviewed your significant figures. Okay, welcome back. In looking at number 1, these zeros are not significant, so there are no significant numbers until you run into one for a number less than 1. So it's like no, 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 and then it'll always be yes from that point on. So yes, 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 3 significant figures. Now, big numbers are the opposite. You sort of start on the other coast here, and it'll always be no, no, no until you run into a non-zero number. So this is about 129,000 inches, plus or minus 1,000 there. So that would be 3 sig figs. So 3 sig figs for number 1, 3 sig figs for number 2. Number 3, if the zeros are in between significant figures, that's the numerical value, so they are exact. So this would have 5 significant figures, and Rule 4 talks about trailing zeros on the right side. So trailing zeros on the right side of the decimal are always significant. They're not up here because that's on the other side of the decimal, but here there's a reason why they wrote 120.00 because it's more accurate. And the answer to this next one would be 5 significant figures for this one. This guy right here is less than 1, so it's no, no, and then it's always yes once you hit a non-zero number. No, no, yes, yes, yes. So this trailing zero on the right side, just like this, is significant. So yes, 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 that is 3 significant figures. Okay, and number 6 also has 3 significant figures because that's a trailing zero on the right side. Additional practice problems, strongly recommended. I know you guys are like, yeah, I got this stuff, but I am giving you some time to work on this, a couple of days to prepare for the quiz. So you might want to hit those problems a little bit and go back to, when you were a little more fine-tuned in the skills of using significant figures, because we haven't used those in a while. So do the odd problems, check them in the back of the book, and correct and perfect them. Okay? All right. So the next thing we're going to talk about is something that's covered in this chapter and is very important. Remember, this course is sort of designed as being related to the medical field. So making measurements is very important. So when you read a graduated cylinder, like on this one, for example, you always read the bottom of that meniscus. So I'll just draw a straight line across there. So you can see that this graduated cylinder is on increments of tenths, okay? So you have 6, 6.1, 6.2. So as you follow up here, there's 6.5, 6.6. So this is 6.6. Now here's the thing with significant figures and measurements. That last digit in an analog scale like this, you have to guess where that is. So you can see that it's a little past the halfway point. It's not 6.7. So 6.6, and then I just said 6.68. Because it just 6.9 would be a little bit closer to the line, I think. This always has a little bit of uncertainty, although we're pretty sure it's pretty close to 6.68. It has a little bit of uncertainty. So what we add to this is plus or minus 0.01. So 6.69, yeah, 6.67, but outside of that range, you're getting to be a pretty bad guesser. Because if you guessed 6.7, for instance, that's only 2 hundredths off. that would be a bad guess. All right. So that's how we look at these problems. And one of the things you'll see on the quiz is I'll just give you a scale like this. And of course, I just included the units there. So it's 6.68 plus or minus 0.01 milliliter. And that gives you the uncertainty in the measurement. But one of the things they'll do on the quiz is they'll say, given this 100 mil graduated cylinder, what is the uncertainty in the measurement? Okay, so they're not going to have the little meniscus there and ask you what the measurement is, but they're going to ask you what the uncertainty is. So the way you do that is, first thing you got to do is figure out what the increments are. Okay, so in this case, the increments, here's 60, there's 70, these each are in the ones position. Now, then go to the right one place, and that's the one that you can guess. Okay, so in this case, this is plus or minus 0.1 milliliters. Okay, so if it has increments to the ones, it is has to be guessed at the 10th position. That's the next decimal place over. Okay. So, and that certainly is something that you want to do just based on how it's looked. Now, if I was in classroom there, I'd show you the great big huge 2,000 mil beaker, and I'd show you that it's incremented at 600, 700, and 800. So that's the 100th position. You'll be able to be for sure accurate, and you'll be guessing to the tens, okay? Plus or minus 10. So you just go one place over from the hundreds, one place to the right brings you to the tens position. So that would be plus or minus 10 milliliters. Okay. So you'll want to be able to answer that just based on what the increments are of the measuring device. And this is in your book. So here's a ruler that is rounded to the nearest centimeter, so you guess one place to the right. Here's one that's incremented one place to the right, so you guess two places to the right. So the uncertainty in each measurement, see if you can think these through before I do them. So in ruler A, what is the uncertainty of that measurement? And the answer is plus or minus 0.1. As you see here, that's the one place to the right that will be uncertain. Now, if it's incremented to the 10th, then you can guess ruler B out to the hundredth, that you have 0.01 plus or minus. So now you know how to do uncertainty. All right. This is in your textbook. I believe, let's see, it's on page 30. And it's just a good summary of everything that we've talked about right here. And the next topic is a little bit more involved, and it's off of the slideshow presentation, but you have a handout that is entitled Significant Figures and Mathematical Operations. I believe it's SF and Mathematical Operations. So we'll be doing that on the next video. I'll be going over that real quickly, and that will be the additional practice that you'll be doing. So I will see you in the next video.